So what are we going to talk about here, Drew?
I think we should first talk about
We're running low on time. We got 7 minutes to make a 15-minute long video.
How do you feel, Matt?
Oh, terrible. All right, so I think we should just, start demonstrating what's going on. So we have our Kubernetes cluster tunneling.
Yeah.
Exposing this ingress address.
Yep.
I have this alias here, otherwise it would be localhost, and we are taking ingress on 443. So, because this is running on my computer, which is a shitter MacBook Pro, this is going to take a good 6 seconds to do reflection. Can do this, perform all of the exact same operations that you could have previously.
We didn't look up anything specific.
Yeah,
probably do like a
list usernames.
Yeah, that's probably a better example to show. We can probably show off our K9s. That looks at least pretty cool, I think.
Yeah. Okay. So I guess we can take a look at our cluster configuration here. So let's get all. We can start talking about some of the pieces. So we have Linkerd here for MTLS because as any good DevOps person would do, you can't trust the your cloud provider that you're hosting your network on. So you gotta, have MTLS to make sure that everything inside of the cluster is secure. Linkerd handles all of this for us. Has a CA certificate that is just inside of this actual cluster.
It's on the control plane of Linkerd.
Yeah.
Yeah.
So all of the services trust that CA.
Mm-hmm.
Otherwise, we're using Nginx for ingress. So we're taking 443 and forwarding it to the service that represents the identity server. The identity server is under a horizontal pod autoscaling group, so we're discriminating on some metrics here. So we're doing CPU utilization.
70% CPU utilization per
that sounds
pod.
Right. Whoops.
HPA.yaml there.
So. Oh, sorry. Yeah. Target CPU utilization 70, and this points to our identity server. So this is hard coded, but whatever. I mean, it's not hard to fix. I'm sure we'll get docked for that, but so I guess a little bit about our consistency model here.
Sure.
So we have a weak consistency model and a high availability model.
It's very highly available.
So we have Redis nodes, which are only read-only, and they are just complete replicas of the master. And they sit there and they can do service discovery for you. So if you connect to one of the Sentinel nodes, you should be able to figure out what the master is. And then because we have these Sentinel nodes here, they do health checks on the master. And the master will, provided that it goes down,
it can spin up a replacement node and then elect a new master.
Yes.
Yeah.
And the Sentinels will decide that based off of the quorum, which is a configuration value that decides the amount of Sentinel nodes that need to agree on the master being down before they start promoting a new master. Yeah, so let's see what else. I guess we can talk a little bit about how we wrote everything.
Oh yeah, we can go through our beautiful
So we
manifests.
have this little script here that does a bunch of things for us, which are just a bunch of bash functions.
Yeah, you basically
here at the bottom.
Spin it up, you can run a series of commands and generate, apply all of our deployments, and apply the Linkerd mesh config, and build the app, Docker image, all that. You can just run a series of commands, get everything spun up. It should, at that point, be able to just run on its own.
Yeah, so Linkerd is handling MTLS, using Minikube for the cluster, which is essentially just running a Kubernetes cluster on a single Docker container. Really fucking slow. Probably not doing the most idiomatic Kubernetes thing. We're using just env substitute to add these environment variables to our deployment template so that we can dynamically give it a host and a port and a password and the actual image itself. We have a pod auto-scaling group set up here. This works. I want to set the in replicas, we would be able to hold up really quickly. Got some shit going on here. Got to add one thing. Fuck, I don't know if I have time. Alright, was that before? Yes, okay, alright, perfect. We had to add one other thing.
Yeah.
Okay, good.
Real
we forgot to add the linker to the bash script, otherwise you wouldn't be able to replicate. Oh my god, fuck, we didn't add.
It's in Discord, Matt.
Oh. Okay, well,
that'll be
we
late.
need to be able to inject this, so
Yeah,
probably
well,
not gonna get the
Linkerd is going to be a little late. I guess that got removed at some point and isn't in our current.
Yeah,
Isn't
we've
in our
been
current
debugging this.
commit there.
Let's see. Highly available, low consistency.
Yeah,
we handling we have fail tolerance
fault.
via fault tolerance. Sorry, yes, via Kubernetes.
If the pod goes down,
So,
it'll spin up a new one.
As you saw, I just
replicate
changed the replicas. We can just change this to 5. We're going to set them into 3. So then if we go into here, I can just do... So then we'll reapply this, and then we should see...
the pod spin up shortly here.
Yeah.
There they go. Starting up.
And then again, just to a little bit of confidence in this working, we can reflect for 10 seconds straight and then make a call. Working. So, and if we're going to be completely transparent here, we did have some issues with readers and writers inside of our cluster. Redis Sentinel is configured in a way where a Redis Sentinel can be can only do reads.
Yeah. So the Sentinel nodes can only do reads, and the master node is the only one that can do writes.
And
our issue lies with
we cannot do service discovery for the actual master node, so we cannot perform writes right now.
I mean, can we not just?
I mean, we can perform a write if it like load balances to the correct pod that can do writing. Had a little bit of issues with that. Otherwise, this is completely persistent. So we're doing append only, or append after file, and the automatic sync, and that's set up by our Helm configuration for Redis. So if we kill this and we restart it, then our data is not lost. It's configured properly for Redis as a primary database. We can, at runtime, as you saw, create these. Redis, same thing. We would just have to go to our Helm configuration here and set it up to set the replica count. You can also set it up properly to... Did it stop recording? Fuck. No, it's going.
Is it?
Yeah, it's going.
Oh.
Stops because
Oh, interesting. Okay, sorry, it disappeared from your touch bar here,
Oh,
so I
shit.
thought it may have. It was giving us real time.
So, yeah. I guess we can talk a little bit about TLS inside of this too, I guess. So we have in the TLS secret space in Kubernetes a secret that's set up in here. So we're just applying this to our cluster here under the TLS secret space, and then inside of our ingress, we're picking up the secret. So there's no way that you'd be able to talk to this server from the outside without the proper certificates, and as well inside of our cluster, because of MTLS, everything is completely secure. I guess we don't really have any automated testing apart from just looking at the nodes and the pods and our services inside of K9s, or just any sort of Kubernetes like dashboard. I think that we can safely assert that this is fine. If you look at the different logs, or if you go to each server and you try to do different things, it will like go to a random one. So we can assert that it definitely is load balancing inside of our service. Again, adding to our high availability.
Do you want to go over the changes you made to the actual application?
Yeah.
It's basically just a shift to using a Jedis pool.
Oh no, we got rid of the Jedis pool.
Oh, is it gone?
Yeah, we don't have Jedis pool anymore.
Oh,
we
wow.
couldn't get that to work. We're just using a single Redis.
Oh, it went way back when that debugging was going down.
Yeah.
Oh, that's about the last 3 hours we
Yeah,
spent.
so I mean, not to mention, we have an idea of how this works, and we understand from the, like, our Helm repository that we're using for Redis. Like, we know exactly how to connect to it. We know what is read and what is write. But we're having some issues connecting to it via Jedis. Jedis is a really, really fucking old Redis client. In the future, I definitely would not be using it. There's like 20 different constructors for Jedis here. Very poor documentation on this. I think that definitely attributed to why we couldn't get writes to be completely consistent, and consistent in the sense that it always works. I guess if we want to go back to our consistency models here, the nature of this application is, to support a lot of like reads. I don't think there are a lot of people I don't think users are created as often as people read a user, so I think that it's appropriate to prioritize reads over writes. However,
and that's not to understate the failing.
Yeah, it definitely is not working.
It's not working.
We're just
properly.
talking about the actual configuration that we have. So this is for read only, and this is for writes. We can connect to both of them, but the Jedis pool configuration for Sentinels is just absolutely shitting the bed. No idea what's wrong. We spent the last 5 hours straight trying to figure this out. Literally 5 hours straight, so
yeah, at some
we kind of
point
need to just turn.
you needed to throw in the towel and get something pushed that was in a reasonably working state.
So it satisfies the criteria. If you
only make reads,
you relax the requirements for reads, this thing will or for writes, this thing reads like a motherfucker.
Oh gosh. Yeah. Any final thoughts, Matt? I think we're probably about where we need to be in terms of description of our of the overall project.
Yeah,
The ups and downs,
I
the
think
failings of it.
learned a lot about Kubernetes. I think this helped me out quite a bit in my lack of understanding. In the future, I'd like to continue learning this more and get something actually working, and not even just working, but deployed on something other than just my computer, because obviously the bottleneck is my absolute fucking dog water computer. Otherwise, everything is set up in a pretty standard Kubernetes way. Security is fine. High availability, you just can't read.
Yeah, going in, I did not know a thing about Kubernetes, and coming out of it, I feel like I know 100% more, and I have an understanding of how to get things working in some sort of way. I think this is basically scratching the surface of its potential, of what we can do, of what we could have done for this project.
Yeah, I guess in retrospect, I can't decide whether or not I would have gone with implementing an algorithm on our own. I feel like I learned a lot at the expense of maybe my grade here.
Yeah, this was an exercise in learning something new and educating ourselves outside of, I think, what was, I wouldn't only say expected, because that implies that we're going above and beyond, maybe wanted. Outside of what was wanted, we forged a different path, and that led to some situations that we couldn't really solve.
I just wanted it to be a little bit more true to an actual deployment. I didn't really like the idea of just hard coding a port on my local host to map to a Redis instance. I think also in retrospect, I would have just implemented our own store using maps and another service or something, because then we could truly get the learning outcome out of this assignment.
But
yeah,
hey, it's in a state where the cluster works. It auto scales. It has high fault tolerance, high availability. Reads work perfectly. So overall, I think it's functional.
All right.
Well, that'll about do it. I think we're both pretty tired and pretty defeated here. So
very defeated.
Hopefully you watched this video despite it being released a little after the deadline here. But
man,
this is what we could do. We put as much time as we could into it. So yeah.
Well, thank you for your time, Arjun. Have a good one.